My name is Rossen Stoyanchev, and welcome to the Spring 1 conference. Welcome to the Web and JavaScript Track. We have a lot of excellent content, and I hope you enjoy the conference. What I'm here to talk about today is Spring 4 web applications. I'll be covering a broader update as well of Spring Web. But before we start, a little bit about me. I am a Spring Framework committer. I've been involved with the framework for a few years now. I focus mainly on Spring MVC and web in general, so this is my area of expertise. I'm also the lead for the Spring 4 WebSocket Messaging support, which is part of Spring Framework 4 that will be covered later on today. So the goal for this talk is basically to provide a update for Spring MVC 4.1, tell you all about what the new features are, provide you with a little bit of detail so that you can go back and put these features to use. But we're not going to limit it exactly to one specific version, which happens to be the one we just released last week. So it's the latest. But there are a lot of features that have evolved over time, so we're not going to try to box it. We're going to put it in the context of other recent releases as well and try to make it kind of a more coherent picture overall. And we're not necessarily going to limit it to Spring Framework as well. If there's something relevant that we can talk about, we'll do so. How many of you are Spring MVC users? I assume everybody here, okay. So Spring MVC Annotations, this is really the programming model that we're using to write web applications. It is very popular, and it has been evolving through feedback ever since I joined the framework. It all started in version 2.5, and REST support, comprehensive REST support was added in 3.0. And from that point on, there have been many refinements in the subsequent versions of 3.x, 3.1, and 3.2. And a lot of these features are being requested. In other words, we make a lot of choices, we make a lot of selections, but the large bulk of these changes are driven from community feedback. You know, we're talking about requests in Jira or things that may start in forums where the application is using Spring MVC in a certain way, and some sort of a challenge or question is encountered, and then that turns into a request, and then it's getting discussed. And this is really what drives an open source project. This is what gives strength to an open source project. And Spring MVC continues to be a very active area of Spring Framework. We're getting always a lot of very good requests. In version 4 of the Spring Framework, we took a fair amount of time to devote to WebSocket messaging. So WebSocket is a large topic. It is very much related to web applications, because if you want to build real-time web applications, that is definitely going to be something that you want to take a look at. But also, WebSocket means a messaging style architecture, which is very different from HTTP REST style architecture that we all know. And that's only just scratching the surface. It's a very large topic on which we have more coverage today. How many of you are actually using any WebSocket in your applications? Okay, so there's a few hands, not very many. How many of you have tried the WebSocket features yet? Okay, a few more hands. We'll talk a little bit about that today, and there's also a presentation later on by Sergi Almar that you can attend as well. And this trend continues basically to evolve the framework through user feedback, through developer feedback and requests. So starting with the central annotation, the central component stereotype in Spring MVC that everybody knows, that's the controller annotation. This is how we indicate that a particular type of Spring Managed Bean is going to be of interest to Spring MVC. And of course, that contains request mapping methods and supporting methods for model attributes for initialization of the data binder and for handling exceptions. We all know that. There's also the REST controller annotation, which you may have seen in the keynote or maybe you already know about. That's a little bit more recent. It's essentially another component stereotype, which means that if you put this annotation on a class and that class is scanned by Spring, you can configure exactly where to scan, then that's going to be essentially declared as a Spring Bean. And actually, I'm not sure if you knew how this actually works, but it's quite simple. The REST controller annotation itself is annotated. This is what we call meta annotated with the controller annotation and the response body annotation. And that takes on a couple of meanings. The first one is that this is an add controller. And the second is that the response body annotation is inherited on all methods automatically, which means that you don't have to put it on every method, which of course you would have to do otherwise. So we basically want to designate this type of controller as a special stereotype that's going to be focused on REST-style interactions. No view templating involved, just basically writes to the body of the response directly. How many of you knew about this one? Okay, some hands, but not too many. This is yet another component stereotype, which is actually very, very useful. The idea is that if you want to have any of these supporting methods like exception handler, model attribute, init binder, typically you put them in the controller or maybe in the base class. So they're scoped to that controller in this way. But in 3.2, we added a controller advice annotation in order to make it possible to have these kinds of methods apply on more than one controller that is not necessarily even in the same controller hierarchy. In fact, by default, these are going to be global, meaning that they're going to apply to every controller. So that allows you to do a few additional things. And this is a component stereotype, which means that it's auto-detected. If you just declare, put this on a class, and it's discovered by Spring, it will be basically managed by Spring, and it's going to be automatically detected by Spring MVC as well. And in addition to making it global, it's also possible to provide more fine-grained indication of which controllers actually it should apply to. So for example, here you see pointing to a class in order to indicate that that's the package or the packages that we're interested in. We're going to be applying controller advice to those specific classes. And there's a few other ways to do it as well. Now, the original request for this came from a request to make exception handler methods global. How can I add a global exception handler method? That was the original request. So we looked into making that possible to add a global exception handler. And then eventually we came down the path of this component stereotype. And there's other useful things you can do about it. For example, you can have model attribute preparation. You can add something to the model for every controller. And that's something that you might have considered doing using a handler interceptor in the past, using the pre-handle method. So there's a little bit of overlap here. But actually, pre-handle is not exactly within the scope of the annotation support. It's basically just the interception point before any handler gets invoked. It doesn't have to be an annotated controller. You can do global data binder initialization. For that, it can be quite useful. It's quite natural to want to initialize certain property editors globally. And as of late, we also have another addition for use cases for controller advice, which is the response body advice. This is something new in 4.1. So the response body advice is basically an interface which you can implement in addition to putting the controller advice annotation. And it's a callback, essentially, for response body and response entity methods. So if you're doing this kind of REST-style interaction in Spring MVC, if you have response body methods, they are going to returns some kind of value, right? The method returns a value, and then that gets written to the response using a message converter. Now, the question is, what if you wanted to do some kind of special processing there? We really didn't have any kind of hook, post-processing hook for that until now. And it's not something that you encounter immediately if you try to write an application, but there are definitely a lot of very good use cases for it that have come up over a period of time. So for example, the Spring Data REST framework, which takes Spring JPA repositories and automatically generates or automatically exposes REST endpoints in order to perform CRUD-style operations. It has to do certain things every time an object is returned. Sometimes it needs to do transformations to these objects, and until now there really wasn't any specific way to do it. Another common use case for this is I don't know if anybody has ever tried to use a post handle method on a handler interceptor in order to modify some kind of headers. So for example, you might remember one particular example was a developer that was supporting annotations on controller methods in order to add instructions for Google for search engine optimization. So put annotation on controller, and then in post handle try to add certain kind of response headers. But you can't really do it in post handle because at that point the response is already committed. If you're using a message converter to write to the body of the response, as soon as you reach the servlet buffer limit, the response gets committed, and at that point you can no longer add headers. So this is why having this kind of callback is basically essential, because without it you really have to go to great lengths to be able to do it. And we have 2 implementations for that already. We've actually found it useful in the framework. JSON view, support for JSON view. How many here are using Jackson? Library for JSON, okay, most hands. Basically, Jackson has a JSON view annotation, which I'll show you in a moment, that allows you to do rendering of a subset of a domain object, if you don't want to render the whole thing, based on a specific request. And we also have JSONP support. How many are doing JSONP in one form or another? Okay, a few hands. How many of you are doing CORS? Cross-origin request. Okay, so let's talk about that first. JSON view. We have a domain class on the left, the user class, and that has a couple of fields, a username and a password. And then at the top we have a marker interface, which can be called anything. Let's call it public view in this case. And then on the right-hand side you see the actual usage of it in Spring MVC. Now in Jackson, basically you can apply rendering. You can turn an object into JSON, and you can also supply an annotation, which is called a JSON view. You supply a JSON view. You supply a JSON view type, and that's the marker interface. You're basically asking for a subset of the domain object to be turned into JSON. And that's something which you can do with Jackson, but now it's supported directly in Spring MVC. And you can see here that on a per request mapping method, we can put the JSON view annotation, which comes from Jackson. That's Jackson annotation. Put it directly on the method. And the meaning of that is that when the user object gets returned, only the username field is going to get rendered, because that's the one which is marked with this annotation. The most obvious use case for this is if you have a detail page and then a list page, and you're rendering the same object, but in each case you want to have a slightly different amount of information. So essentially, yeah, here we're using the ResponseBodyAdvice in order to make this happen. If you are using view resolvers, there's also a way to do exactly the same thing, but it's not through the JSON view annotation here. It's rather by adding an attribute to the model, and the name of the attribute is actually the class of the JSON view annotation. So it's slightly different, but it's more in line with the way view resolvers work. The next one is JSONP support. This is something which has been a little bit difficult. It's been requested for a while. It's been difficult to add because we didn't have this kind of callback. So even within the framework, we were constrained to the contract of the HTTP message converter, which does not give you access to the request when you're writing to the response. You know, it's one of those things when you create a contract for a long time to be, you give it your best, and then after a while, something comes up that kind of challenges you on how exactly to do that. But the ResponseBodyAdvice actually gives us a way to achieve that. So if you have JSONP, all you have to do is declare this as a Spring Managed Bean, essentially extending this base class and giving the name of the JSONP query parameter. And there's also a way to support this with view resolvers. It's actually, you don't even have to do anything as long as the query parameter name fits what you use in the application. Some other changes. In Spring MVC now we support the java.util optional as a method argument on request mapping methods. The meaning of that is essentially wherever you have any of those annotations that have a required flag, which may be true or false, we now support the optional type, which means that you can declare it. You don't even have to put the required flag. You know, that automatically tells us that what you want here is something that should be not required all the time. And you can see here an example of using it. It's the request param, it's the request header, it's the matrix variable, any of those annotations that have the required flag on them. How many Java 8 users? Developers, applications? Okay, not many hands. Another new type is the ListenableFuture. This is supported as a return type in Spring MVC on request mapping methods. If anyone is familiar with the Servlet 3 async support, essentially it allows you to support things like long polling requests without keeping the thread. So it allows you to scale and support long polling. Well, the typical way to do it is to return a deferred result or a callable. Now we also support ListenableFuture. And for those of you who don't know, ListenableFuture came with the async REST template. And the async REST template, how many knew about the async REST template or maybe even using it? Okay, a few hands. So we have an async REST template alternative to the REST template, which allows you to make an asynchronous invocation to the server and obtain the response without holding the current thread. So you might get notified when the actual response comes back, which means that if you're, for example, doing a lot of concurrent requests, it means that you can just get notifications back, which is just a different style, a more asynchronous style of communicating. And this is actually very appropriate on the server side. If you're actually processing some kind of a request and then you want to turn around and call another REST service, then the async REST template is a perfect fit for that, because it means that you can release the thread while this information is being obtained. Maybe the other REST service is slow. And you can also release the servlet container thread. So basically just return ListenableFuture from the request mapping method. And then everything should work as it would in the synchronous case. Another noteworthy item, in Spring MVC controllers, we have model attribute methods. And model attribute methods are invoked in an order which is not guaranteed. Now, this hasn't been an issue for a long time, because actually the order of declaration within the class is always the way it's worked out. So if you ever kind of relied on that, that order was broken with a specific version of JDK. You know, how exactly, what order you get the methods in when you use reflection is dependent on the JDK, so it's not guaranteed. But basically what we decided to do for that is to respect the interdependencies as they may be deduced from the method declarations and invoke them in the right order. So in this case, you have a method that returns or adds a foo object to the model. And then you have a second method which adds an object called bar, but it also declares that it needs an object called foo. So there's an obvious dependency there. So basically what we do is we keep trying until we can find an order in which we can invoke these methods to satisfy these dependencies. So it's kind of a subtle enhancement which is there now. In terms of HTTP message converter additions, we have actually several new ones in Spring MVC 4.1. The first one is JSON, and that's something which came through the Spring Android project. It's been in use there for a while because it has a lighter footprint versus JSON. And basically, if you are already using Spring Android project, maybe you have some part of your application, doing that, and then another part of your application that has a regular web application, then you probably don't want to use two different, JSON serialization mechanisms. So it kind of makes sense to have this in the core Spring framework so that you can use the same converter. Google Protocol buffers. This is a request that's been there for a while that we addressed in 4.1. Basically, Google Protocol buffers. Anybody using Google Protocol buffers, by the way? All right, a few hands. So Google Protocol buffers is actually inter-service data protocol. It defines the kind of data that you can put on the wire, and then it's supported in multiple languages. I believe it's Java and C++ and Python. And you can basically have code generated that represents that data in each of those languages, and then you can work with that code. You can work with that data. So this is actually what Google uses internally within their architecture. And this is something which is actually quite effective within an enterprise as a language for communicating with other services. So this is basically how we position this, how we've decided to add it. We have an HTTP message converter that you can use. Obviously, you can use it on the client side with the REST template, or you can use it on the server side as well. And there's also a way to expose it as JSON or as XML. So these are also built into the converter. So if you already support Google Protocol buffers, you can now expose also JSON services as well. Google Protocol buffers also has the advantage of being very fast. So that's also another attraction there. JSON, we've added support for JSON XML serialization. So if you're doing JSON, you can now also use JSON for doing XML serialization. So if you remember that JSON view annotation we talked about, that's one of the advantages of using JSON for both XML and JSON. You can now use it for both. This is a good one because it's kind of really easy to take this and apply it to existing code. And it's kind of a pleasure to delete lines of code and replace them with something shorter and more compact. So ResponseEntity, which I'm sure you're familiar with, you can see at the top an example of what it takes today to create a response entity. And it's pretty straightforward. It's a constructor which takes a few arguments, but once you start adding headers, it becomes a little bit verbose. So you have to say, ooh, looks like I'm missing a line here. So you have to say HTTP headers. You have to create an instance of HTTP headers, and then you have to set the location on that, and then you can pass it into, this is called programming in PowerPoint. No compiler checks. But you can get the point here that we even would have an extra line at the top. And then at the bottom is the alternative version of that. The ResponseEntity provides these static methods which give you builder-style options. Now, what's really nice about this is, how actually this request came to be is that we have the HTTP headers, which lists all the headers that we know about or that we use. And they're both client and server-side headers, which means that if you start now creating HTTP headers, you have to choose which ones are applicable on the server side, which ones are applicable on the client side. There's no guidance, basically, in that. Whereas what we've created here with the ResponseEntity is if you were to look at those methods there, for example, ResponseEntity created, that's a very specific scenario that's built into it. If you're responding on the server side, this is a very common situation that you want to return a 201 with a location. And also, create a body for the response. So there's a lot of guidance built into that and lets you pick exactly the headers that you need. On the client side, there's actually a new type called RequestEntity. You can see at the top that actually what you would have to do is create an HTTP headers. You have to create an HTTP entity and then pass that into the REST template. So the REST template is great, when you have, doing common things like get and post, just passing the body, getting a response body back or response entity. But once you want to, add headers or do something more advanced, it becomes more verbose. And that's really what this is addressing. You can see here that, well, surely you no longer say get for object or post for object, but you can see that the bottom is actually pretty readable and is pretty compact. We have something else here that would be of interest, I think, to many. The ability to create links. This is, again, something that's been of interest for quite some time, to create links to annotated controllers. So the question here is, if I have an annotated controller and I want to link to it, I may be doing that maybe from my controller, performing a redirect, or maybe from a view, if I want to create a form and that form needs to point to one of my controllers. The request there is, how do I avoid hard coding that URL into my JSP or wherever it may be, or on a redirect. So you can see a controller at the bottom, and that controller contains a lot of the information that we need to create that link. So we have a request mapping on the type level with a URL, and we have also a request mapping on the method level. And they each have a URI variable, and that's getting passed into the controller method. And at the top, you see an example of creating a link to this class through the MVC URI components builder. So this is the sort of extension of the URI components builder, which gives you additional methods to do this. And this is going to be something that's very similar to using a mock framework, for example, where you declare the type for which you want to create a mock, and then you can invoke its methods, but it's not actually performing what the actual implementation does, but it's doing some test-related things. Well, in this case, we're pointing to the controller class, and we're essentially creating a proxy for it internally in order to be able to invoke its methods, and by that indicate what we want to create a link to. So by invoking the getAddress method, we're actually going to prepare a link based on the information which is in the class. And you can see also that we're passing the parameter to the getAddress method because we want to supply the information for the URI variable in order to fill in on the URL. Now, in addition to that, in 4.1, we've actually created request mapping names. And you'll see in a moment why this is important. But basically, there's a strategy which assigns a default name to every request mapping method, which means that you can then refer to it by name. So if you have a class called myController with a method called getAddress, the default name which gets assigned is based on the capital letters of the class name, followed by hash, followed by the method name. And for example, if you were to take this and paste it into an IDE, they'll typically get you right there, because that's a sort of a common convention for a short way of typing the class name. You can see what mapping name is assigned to each request mapping method on startup by enabling trace for Org Spring Framework Web. And if you notice that there are any kind of collisions, in most cases this is going to work out fine. But if you have any methods that are overriding, overloaded methods, then you will have a collision. And in that case, you can actually use the name attribute on the request mapping annotation to give it an explicit name in order to break that collision. Of course, you can implement your own strategy as well if you want to kind of have a different way of naming these classes. Okay, so how do we actually make use of this? Well, the MVC URI components builder actually now has a new method called fromMappingName. So now I can say, I want to create a link to that controller method, and I'm going to provide the name for that method. And then also we need to insert some arguments. And you can see here that we can insert argument at index 0. Now you may be wondering, why are we doing here inserting an argument with an index, whereas back here we are just invoking the getAddress method. If you have multiple parameters here, you can actually supply null for those that aren't part of the building of the URI. But over here, if the controller method has more arguments, you can simply skip them. And the reason for that is because if you imagine doing this in a JSP page, you can see here building a URL. That's the ultimate goal here, to try to build a link within the JSP or some other view technology. You can see that we're trying to keep the syntax as short as possible. So basically, we're just referring to the controller method by name. And then we may have to provide an argument in there in order to fill in. So that's the basic mechanism available. But foundationally, it's the MVC URI components builder that needs to be invoked. And in the case of JSP, we've provided a function in the Spring tag, JSP tag library. So you can use that in JSPs. But obviously, in any view technology can be used as well. Any questions on this? Yes? OK, so the question is, can we specify the get versus the post? Right, so that information is coming from, well, we're mainly constructing a URL here. So if we look at this example here in the JSP, you'll see that there's no indication of the HTTP method. We're simply constructing a URL, which then we can put in a form tag, which has an action. So you have to choose at that point get versus post. But that's, I think, that's not so bad, because at that point you probably know most of them are going to be post anyway. You kind of know post versus get. That's a little different from hard coding the URL. So the question is about free marker and velocity versus the free marker and velocity macros versus the JSP tag library. There's nothing at the moment in the free marker and velocity library for that, but the underlying mechanism is the MVC URI components builder. So basically, that's what needs to be invoked at some point, which can be done from any view technology. To some degree, the MVC URL is a bit static function here is a bit of an experiment. There's probably better ways that we can think of, and at that point we can add them to free marker and velocity. But this seems like a good start. Any other back there? How do you pass the ID? Yeah, this is something that I notice here that's missing. It actually needs to be. This is a typo here in the getAddress method. That should have the ID as well, right? Because if it's in the URL, we probably care to get it into the request mapping method. But this is another PowerPoint programming cut and paste there. OK, so moving on. So we have a large topic that's going to come up tomorrow on static resource handling. This is a major feature of Spring Framework 4.1. And it's a presentation that we'll be doing tomorrow morning. But this is a topic that's probably going to relate to pretty much any web application. We're talking here about a comprehensive strategy for dealing with static resources. So probably many of you know that we have the resource HTTP request handler, or a mechanism for serving static resources in Spring MVC, which basically means that you can take JavaScript or CSS files and you can serve them through Spring MVC. And they can be located on the class path. They can be located under the root of the web application. And that simple mechanism, of course, leaves a lot of things that still need to be solved. If you're working with JavaScript, if you're working with CSS, you have to figure out a strategy for example, optimizing those resources, for concatenating them, for minifying them. Also, you have to figure out strategies for cache busting, maybe inserting a version in the URL in order to be able to effectively replace those resources when necessary in the browser, but also make sure that it's efficient, because if you have a web page which has 20 or 30 HTTP requests, which is not uncommon in web applications. If you have CSS files, if you have images, suddenly your page requires 30 or 40 requests. And even if you have E tags and those kinds of things on the server side and returning 304s, that's still 20 or 30 requests per page. So if you have a mobile device and you're just waiting for this thing to come back, it just takes a while even for back and forth requests to the server. So for that reason, it's very important to have a good caching strategy and a good versioning strategy that's going to make sure that these resources are cached for as long as they don't change, and you're not going to see any additional requests. In fact, Brian Clausell is talking in the adjacent room on Sagan, which is the Spring.io website, and it's something that we'll be talking a little bit about tomorrow as well. And when that went live first, they ran exactly into those kinds of issues, which is very predictable. So basically, in Spring Framework 4.1, we have a strategy for working with these features and for working with resources. We have a couple of new contracts, a resource resolver and a resource transformer, which are used to form chains. So you have a chain of resolvers and a chain of transformers. And just to give you an idea of what these resolvers could do, so instead of simply finding jQuery.js somewhere under a specific location, let's say it's under /js, you could do some more fancy things. So for example, you may get a request for a specific resource, and if you don't find it, you can then check to see, is there an accepting coding that allows gzipping? And if that's the case, then you can take a look to see if there's a .gz extension, if there's a file with that extension that's present, and then try to resolve that into a resource. So there's a lot of things that you can do in a chain of resolvers in order to work with these kinds of things. We can be talking also about using less and CSS transpilation, trying to find the transpiled version. So you may be asking for a CSS file, then we can try to look up for a .less extension as well. There are tons and tons of things that can be done. And transformers can actually completely change the resource before serving it. And another aspect to that is inserting a version into the URL. This is something which is known as fingerprinting in Ruby on Rails, fingerprinting URLs. So there's the asset pipeline in Ruby on Rails, and fingerprinting is one of its features. And we had a request in Spring MVC to support fingerprinting. And just briefly, what fingerprinting means is that when you're serving, say, a JavaScript file, you can calculate a hash from its content, kind of the way that Git does. And you can take that hash and insert it as a version in the URL. And now this URL becomes unique. Next time that the file is requested, you calculate once again from the content of the file a version, and then serve a different URL, which means that you can now cache that resource in the browser for, say, 1 year. And the browser is never going to ask for this again until its content actually changes. So it's kind of a very handy, it's called a cache busting strategy, because you're forcing the browser to cache a resource until it actually changes. So it's very effective caching strategy. And this is also something which can be supported with a resource resolver. We, in fact, have a version resource resolver in Spring Framework 4.1, which does exactly that. And of course, if we talk about inserting things into the URL, that means that now when we're serving HTML pages that contain links to resources, those links need to be rewritten as well. If we're serving, for example, an HTML file that points to CSS files, those links have to contain a version in them, right? So they need to be at some point updated and modified. So that's what we have the resource URL provider for, which is going to help to prepare public resource URLs. And all of this sort of forms the foundation for resource handling, for preparing different strategies, maybe even building an asset pipeline on top of it. Now, the resource URL provider actually internally delegates to the resource resolver chain, which means that a part of the resource resolver strategy it's kind of a two-pronged strategy. On the one hand, how can I find a resource given a URL? But on the other hand, what kind of URL should I give to the client for this particular resource? So that's kind of two sides of the same question, the same contract. Right, so this is the fingerprinting URLs that I mentioned. We have a content, essentially that's content-based versioning, to kind of avoid using a term that you may not be familiar with. And you can see here an example of Spring Framework 4.1 configuration. This is something that we support out of the box because versioning is a server-side concern. Again, these are topics that we're going to be talking about in a lot of detail tomorrow. I recommend that talk if this is something of interest. Basically, you can do a lot of optimization of client-side resources using JavaScript build tools like Gulp or Grunt. You can concatenate, you can minify. It's really a very rich ecosystem of things that you can do with it. But versioning remains a server-side concern. So we have to kind of do that on the server side, and this is a feature that we provide out of the box. So you can see here what we're doing is we have a version resource resolver that's being created. And in this case, we're using a fixed version strategy, which means that we're going to assign a concrete version as a prefix. But there's also, we could add here a content version strategy, which is really what gives us the fingerprinting URLs. And as you can see, the important thing here is that we can assign specific patterns, so we can support different strategies for versioning with different resources. Now, why is it important to have patterns here? Why should we do a fixed version strategy for one set of resources and content version strategy for another? Well, because, for example, what you see in the bottom here, an example of a fingerprinting URL, JavaScript module loaders. How many of you are using a JavaScript module loader on the client side? Okay, so there's a few hands. And as you know, JavaScript module loaders, which is a great practice for client-side code, actually needs to know about what JavaScript components there are. So it needs to know the links, relative links. It can do optimization of those files. So you can't really use fingerprinting URLs with JavaScript module loaders, which means that you have to be able to apply different version strategies to different types of resources. By the way, that should say add content version strategy there for the example at the bottom to work. That's something that is a typo here. So resource handling, there's a lot more to discuss here. The optimization of resources, effective HTTP caching. I just mentioned briefly a little bit about all this, but there's a talk tomorrow where we're going to kind of go over the history of how these features came to be and what are the design decisions that we went through and how we settled on what we have. Kind of give you a little bit more guidance, and that's a talk which is going to be tomorrow morning, same time slot, 8:30 in the morning. All right. For a long time, we've been getting questions about, is there going to be another modern templating technology supported besides the ones we had for how many years, FreeMarker, Velocity, JSP. pretty much we've all agreed for a long time that JSPs aren't really the answer for view technology. It's very common, but there's a lot of issues with using JSPs and allowing kind of the full Java syntax in templates. Certainly ThymeLeaf has filled in a great void there. It's become very popular very quickly, exactly because it fits that goal of providing some sort of a modern templating alternative. Here we have another option which is available in 4.1. So yesterday in the keynote you probably heard about the new Groovy 2.3 support of templating especially for XML, for generating XML-like syntax, including XML, XHTML, and HTML5. And essentially this is a dry markup type view technology, which in my opinion is kind of the only one in its kind. I mean, in Java, we really haven't had this sort of option. If you look to Ruby on Rails, there's Haml. There are choices there which can be used to create markup, which is very minimal. Just focus on producing what you need, and it's much more readable and easy to work with. So here we have a Groovy DSL, which has tons of advantages, and it's actually compiled. It's type checking. It has the brevity that we need, and it's definitely a very, very promising option that I think is an exciting new feature that's available. And this is something that we support in Spring MVC 4.1. It kind of built into the framework. We have a Groovy markup view and view resolver and configurer, similar to what we have for FreeMarker and Velocity. It's kind of really very parallel to that. Something worth checking out. At the moment, we don't yet have the equivalent of the form tags, kind of wrapping the Spring's binding and validation support there. Sorry, an error showing errors. This is basically a very good start, and actually, because it is Groovy, it means that you can register callbacks and closures, and you can do a lot of that stuff essentially just by registering it directly. It's very flexible. And while we're talking about view resolvers, here is something new in the Java config. You can see here that we have finally added support for configuring view resolvers, and probably the key use case for that here is combining content negotiation with view resolution. How many using view resolution? View resolvers in one form or another? Okay, so you probably know how much more configuration it takes to do that with content negotiation. So the goal here is to simplify the registration for that. In this case, we're saying we're going to be rendering JSP pages, and we're also going to use the content negotiating view resolver. And if we can't find, the default view for that is going to the mapping Jackson JSON view, which means that if the client indicates JSON in the accept header, for example, or .json in the URL, we'll end up rendering with JSON, but otherwise we're going to render with JSP HTML. And the same thing can be done in XML as well. Here the full class name is abbreviated a little bit to fit it, but you can see the value there. Once again, if you see this done in XML otherwise with the content negotiating view resolver, it's quite extensive. Another enhancement to the MVC configuration is support for redirect and status controllers. Basically, we already have the view controllers, which means that you can assign a URL to a particular view, and you can render without any controller logic. So if you can imagine an annotated class which has a method, and all it does is just return the view name, well, there's no point to that controller. That's the purpose of the view controller. It's basically a logicless controller that simply maps the URL to a specific view. And the specific request that came was actually not to extend the view controllers, but the request was to provide a way to register mappings for things like redirects or for things like specific status responses that need to be automated. So I believe the request kind of explanation was that there are many cases when for search engine optimization reasons or sometimes browsers will submit URLs that you know are kind of junk and you don't really want to have those be processed. So what you can do there is you can basically prepare a whole bunch of responses to be automated. For example, in this case, we can say status not found, HTTP status not found for that particular URL. Or we can provide a redirect view controller that says this is the old path and this is the new path. And there's actually a few extra options which I'm going to show you through the XML. You can see here, and they're equivalent. So both of these are in Java and XML. But you can see that we're redirecting from the old path to the new path. And then we can say, what's the exact status code? Because as you know, there are like a few thousand status redirect codes by now. And you can also choose to keep the query parameters or not. That's another option. So the incoming URL, as you redirect, you might decide that the query parameters should remain. Whether that should be context relative or not. And then same for the status controller. We have that in XML too. So I mentioned the WebSocket support. Again, there's a presentation that you can attend to get a lot of detail. It's a very large topic, I should warn you. There's quite a bit to learn there. But we think that the programming model that we have is actually quite straightforward. And that's what I'm going to try to kind of show you in just a few slides. Hopefully get you interested in the subject. If you haven't had a chance to take a look. But basically, this is something that we introduced in version 4 of the Spring Framework. It was a major theme, including 2 new modules. The Spring Messaging module was new in Spring Framework 4. The Spring WebSocket module was also new. And essentially, what we have there is a foundational WebSocket API, which allows you to work with different WebSocket engines. They can be JSR 356 or not. And then, in addition, outside of the like the JSR 356 support, we have a SOC.js layer, which is absolutely crucial for working with WebSocket today, because because there's a lot of browser versions that are going to have varying degree of support. For example, Internet Explorer 9. Version 10 is actually required for WebSocket support, which means that most of your clients today are not going to be able to use it otherwise. And there's also, in addition to that, there's still a lot of networking issues related to using WebSocket in a real public application. So for this reason, the SOC.js protocol and library exists. Well, actually, there's many libraries. There's one for the client side, JavaScript based. Which basically means that you're using the same WebSocket API, but if the WebSocket transport doesn't work for some reason, it falls back and it's doing HTTP long polling or streaming, simulating WebSocket using HTTP. But your application doesn't change. Your application is still using the same APIs. And there's essentially a wide range of browser versions supported. Really, that's the purpose of the existence for SOC.js. Hopefully, one day we won't need it anymore. But I think it will be a while before we get there. So for now, this is something that we support in the Spring Framework. And then the other major piece, really, this is where we think WebSocket is most interesting in the way applications should consume it, is through a high-level sub-protocol. Because WebSocket is a very, very low-level protocol, which really doesn't give you much more than a blank page. It just gives you a message and says, if you imagine a TCP protocol, it's just a stream of bytes, right? You can imagine that's very low-level. Well, WebSocket comes along and says, OK, I'm going to break this stream of bytes into messages. Now you've got messages. But you still have really nothing to work with there. It's up to you to come up what's in those messages. Should you put a command on the first line to say what kind of message is this? It's hard to build a framework on top of WebSocket that isn't much more than just a simple callback that says, here, a message came. STOMP is actually a protocol that we can use on top of WebSocket. And by the way, you can think of HTTP as being a protocol on top of TCP, right? Imagine trying to work web applications and REST without HTTP. That's really the level on which WebSocket is. But STOMP gives us a kind of a messaging protocol that we can use on top of WebSocket. And that enables the controller, enables us to do something on the level of add controllers. So you can see here the architecture that we can have WebSocket API underlying the higher level messaging support through STOMP. And then beneath all that, we still have to use SockJS today because that's the way to make it work in all clients. And then we have the controllers at the very top so we can write applications. And I'll just show you a quick example. Again, it's not my goal here to be very detailed on this topic, but I'll show you a quick example of a STOMP message just to demonstrate how straightforward it can be to understand what's going on here. So on the right-hand side, you have an example of the syntax that a STOMP frame takes. And you have a command at the very top. Then you have a pair of header names and values. And then you have a blank line, and then you have the body. And you can see on the left a specific example of that. There's a content type that says what kind of body we have. There's a destination, which says, what is this message addressed to? And then there's a send, there's a few commands. So that kind of gives you an idea. I mean, this is very much influenced by HTTP. It's meant to be used in kind of a web environment. Traditionally, historically, STOMP came from trying to take brokers like JMS brokers or AMQP and exposing that kind of messaging outside the enterprise over the web. And this is really what this protocol is intended to be, kind of an HTTP inspired, still focused on messaging principles and messaging architecture. Now, just to give you a more concrete idea, in a Spring MVC controller, some of the things that you can do. Say, for example, that you have a controller which is doing just a good old request mapping post, adding an account, saving an account. So that's a typical CRUD operation. Now, you can imagine having some clients want to receive updates as they become available. That's a kind of a server-side push. And to make these push notifications is very, very simple. Once you enable the WebSocket and STOMP messaging support, you basically inject a messaging template into any code, including a controller. And you can send updates, in this case, to a destination called /topic/accounts. And then as many subscribers as they are, they will receive a notification. Immediately, it will be sent down to them. So that's an example of how you can take an existing application, which is doing your typical REST and HTTP processing, and you can extend that with some kind of push notification mechanism. And then the rest of this, which I'm not showing here, there's actually a pretty straightforward @enable annotation and an XML equivalent to get up and running. It's pretty straightforward to get to that point. And then also, I wanted to show here that the controller annotation can accommodate now both message mapping and request mapping methods. In fact, this is very intentional. Messaging is a very different architecture from REST, but there's no need to, these are at the same time very related kinds of things. It's all a web application. If I'm processing WebSocket-style messages, that's still part of my web application. So supporting a similar kind of programming model makes a lot of sense. You can see here the message mapping method essentially means that we're taking incoming STOMP message, which is going to a destination/trade. We're going to pass it into this method, and then the body of the content we're going to convert with a message converter, turn it into trade. Again, very similar to what we know from HTTP and REST. And then there's a request mapping method in the same controller, so you can really mix those into one. There's much more on this topic. The presentation that you can attend to get a much more in-depth understanding if this is of interest to you is at 12:45 today. Sergi Almar is going to talk about that, and he has a very nice sample as well, application to demo. So if you're interested, definitely take a look at that. Yet another important subject to web developers is Spring Boot. So Spring Boot, you saw that demoed hopefully last night. And it is essentially a tool for getting started quickly. That's its whole purpose of existence, to be a one-stop shop for Spring application development. So instead of going to many project pages, you basically use Spring Boot in order to get quickly, into production-ready applications. And it builds on many Spring projects, and it does a lot of heavy lifting, essentially. I mean, if you really go down the road of building an application, as you know, you have to solve a lot of questions. You have to decide where should I put my files, how should I configure my Spring MVC application, what kind of message converters should I register, and should I customize my object mapper. Like, there's really tons of questions along the way. What kind of view technology should I use? But many times what you really are after, you want to develop an application, and you want to say, well, why don't you make a very good choice for me? What's the common case? And then if I want to change that, I will change that. So that's kind of a very different way of thinking about it. And in the Spring framework, we've always traditionally maintained kind of a perspective of being very flexible, which is very, very appreciated in many, because it's used in so many different projects in so many different ways, that changing that mindset is really going to affect a lot of projects which really rely on it. But at the same time, there's a big demand, as we've seen with the quick adoption of Boot. There's a big demand for that rapid application development mode. And the two things aren't mutually exclusive. It doesn't have to be either or. And that's really the goal of Spring Boot, is to fill in and to meet that kind of demand, to make it easy to get started. So it's basically focused on the 80% common case. It is much more opinionated, which means that it can be more instantly useful to you. But I think the unique thing that actually, why Dave was talking about all the developers embracing it within the Spring team as well, is because it doesn't do any gimmicky stuff. It actually remains flexible. It gets out of the way if you try to put your own configuration. And by gimmicky, I mean it doesn't do code generation, for example. So that's a very specific principle that Spring Boot stays away from. And it really tries to remain as transparent as possible, so that if you add your own enable web MVC annotation, you can basically take over and you can replace parts or all of it. It's kind of trying to strike a balance there. You can really be up and running in minutes. This is kind of always been the, when we look to the Ruby on Rails, for example, world, it's like, what's our answer, to being able to, or Node.js, what's our answer to being able to do the same in Java? Well, this is really what this is about. The whole application is right here in front of you, and you just say Maven Spring Boot run, and the Maven file is very, very short, like one dependency, basically. So it's really easy to get started in Java and to be up and running literally in minutes. No need to configure the embedded or the servlet container. No need to to make a lot of choices that you have to make just to get up and running. And that's always been kind of a frustrating aspect of Java application development. So basically, Spring Boot is not specific necessarily, not limited to web applications. In fact, it's much more broad and encompassing than that. But certainly, web applications is one of its main uses. It's how most people actually have some sort of web layer in the application. So it is the same Spring MVC programming model that you know. You're not moving away from that. But its purpose is to be basically ready for production, which means that it gives you configuration, it gives you conventions, smart conventions. It gives you an embedded servlet container. It gives you metrics. It gives you logging support out of the box so that you can just basically focus on delivering code. So in that sense, it's kind of a new direction there, one that's a little bit different goal than the Spring Framework itself. And there's certainly worth learning about that. There's a talk today at 2:30 by Phil and Dave, two of the the lead developers of the project, and they are going to take you through and give you a breakdown of just kind of Spring Boot. You know, it's kind of a different way to consume what you already know, so it's worth learning basically about Spring Boot and the way that it does things. On the side of Spring MVC Test, how many are using Spring MVC Test? Okay, and the rest of you are writing applications with no bugs. So Spring MVC Test is definitely very useful for testing Spring MVC applications. It basically allows you to run without a servlet container, but still test your annotated controller methods. It has a nice fluid API to do that, so definitely check it out as an option. What's new in Spring Framework 4.1 is that you can now assert JSON responses. So until now, primarily you could do JSON path, which is very, very useful, you know, for validating responses. But sometimes you just want to validate the entire JSON response. And of course, XML unit has been doing that for us, kind of ignoring little white space differences, new lines, and slight differences in how it's exactly rendered. And this is really what the Skyscreamer JSON assert library can do, and that's now been integrated. Also, we have support for the async REST template, if you're using that in your application. And then yet another option, if you're writing a lot of these tests that might be of interest, is actually the mock MVC builder now has a new configuration point, which I call a recipe. If you have these kinds of recipes for specific ways in which to configure mock MVC. An example of that is Spring Security, which needs to inject certain kinds of things into every request when you're doing testing, a principal, the user, or it needs to also do some setup on the mock MVC itself. And what's a nice, easy way to plug that in so that it doesn't become verbose? Basically, that's the goal of the mock MVC configure. If you have these kinds of recipes in your own tests, then you can consider doing something like it and taking advantage of it. Also, there's an HTML unit extension for Spring MVC test, which is not 1.0 yet, but there's been quite a bit of development on it lately. So it's getting more and more ready. Definitely worth checking out. It's basically a separate project led by Rob Winch, which is essentially an integration between HTML unit and, of course, also WebDriver, which means that you can write Selenium tests as well and use Jeb with your Spring MVC test setup. So basically, you're writing an HTML unit test. You're then using Spring MVC, the mock MVC setup, which means that there's no need for running a servlet container. And you're actually verifying the HTML. You're using HTML unit APIs or Selenium against that. So that's kind of the brief description of it. And there's a presentation which is actually going to cover a lot more than that. I think it's going to talk also about testing strategies and a few other tools. So definitely worth attending that if you're looking for advice on the side of testing. And there's a lot more good content that we have in the Web and JavaScript track. We have talks on single-page apps that you can check out. We have talks on JavaScript with Rave.js that is also worth checking out. So definitely take a look at the schedule for the Web and JavaScript track. And I think the main challenge is in kind of making up your mind where to be. But thankfully this year we have the recordings, so that means that you can still take a look at these presentations later on. So that's pretty much all I had to talk about today. Questions? Yes?
You talked about the static resource trending. What about the static resources coming from an NFS unshared via a CMS system? How does that work?
So the question relates to static resource handling and how to serve resources from a file system, NFS-mounted file system, content management. So we have, the resource HTTP request handler. Have you looked into extending that? Basically, its purpose is to be able to serve resources from any location. So if you're familiar with the Spring resource abstraction, it's an abstraction for finding files anywhere. So that would be where I would look for customizations. So for example, we can load classes from the class path. If you look at the resource, there's a class type called resource in the Spring framework, in the core Spring framework. And that is a class which has a number of implementations for finding resources wherever they may be. That's kind of a fundamental feature of the application context. They may be on the class path on the file system, in JNDI. They could be in a variety of places that are not even file systems, or under the web root. So that would be where I would look, actually. Yes? So question about adding a JSON option to the HTTP message converters based on Groovy. Yeah, feature request, please. That would be a great idea. Is there a specific library or just a Groovy JSON? Yeah, they did some work recently. Yeah. Right. Yeah. Yeah, I think it makes a lot of sense. I mean, we've been adding various places support for Groovy. In 4.0, we added support for bean definitions through Groovy. Now we have the Groovy markup template engine support, which means that there are many reasons why you may already have Groovy on your class path. So, okay. I think we could also probably put it in core as well, but sounds like there's already some work there. Which JSR? Oh, JAX-RS. Okay, so the question is about a comparison between JAX-RS and pros and cons to each. Okay, well, that would be another presentation probably. There's many ways to approach this. I don't think that going down a list of advantages and disadvantages is necessarily going to provide an outcome. I think the bottom line is that they're each serving a similar purpose, right? You can build REST applications using JAX-RS. You can build REST applications using Spring MVC. And with Spring MVC, you can also build web applications, by the way. So, there's support for HTML templating. It's kind of traditionally actually been an MVC framework which evolved into a also supporting REST, but in a slightly more flexible model. So while JAX-RS has the resource-oriented sort of programming model, in Spring MVC, it's more of a controller which isn't necessarily saying this is REST, but it's up to you how to organize your controller. So it's a bit more flexible there. But I think they're really both great options. It's very difficult to sort of say one is better than the other. I think the strengths of Spring MVC again are that it is both a web framework and for traditional HTML web applications and a REST web framework. So it combines these two things very well. And incidentally, there's now talk about a new MVC JSR, and one of the major question marks there is whether to build that into JAX-RS or whether to rely on the JAX-RS mappings or not. So you can see these questions coming into the JAX-RS or into the JSR umbrella. And that's something which we've always had in Spring MVC, which I think is very, very useful because you can't say REST is not web. REST is web, and so is HTML web applications, and very often they're kind of all together in one application. I think the other strengths of Spring MVC is its community. It has a very strong community, a very wide body of knowledge, which means that the requests that we get are going to be very quality, very good requests, and they drive the direction of the project. It's very flexible, so it can be used for a lot of different ways. So depending on what you're doing, you can go with Spring Boot if you want rapid application development, or if you're developing a framework for the cloud, you can use very advanced features and extensions and hook points. That's really where I think Spring MVC shines. But again, I'm not going to say that it's better than JAX-RS. I think if you like JAX-RS and if it does what you need it to do, use it. Over there. So the question is, with the Spring WebSocket and messaging support, if you can receive updates for any number of subscribers, but what if you have a distributed app with multiple web application instances? How does that work? Yeah, so basically that's something that Sergey is going to talk about later today as well. But when you talk about publish subscribe, implicitly we're talking about having some kind of a message broker, something that's going to record all the subscriptions and then publish to all the subscribers. And we have support for a simple broker, which is built in, easy to get started. But then you can also plug in a real broker like RabbitMQ or ActiveMQ and use that as your broker. So you can imagine, for example, if you're running in a cloud environment, you can have a RabbitMQ service, and you can bind to that, and then you can have multiple application instances that it's basically a central message broker that's going to distribute messages. Over here.
You mentioned that Spring Boot provides some metrics out of the box. Can you talk a little bit about what those are?
Yeah, so the metrics, we're talking about things like how many HTTP requests have been made, how many of them have had status of 200, have been successful. I don't really know all the metrics. Dave is right there. He can probably say more about that. But it's the kinds of things that you want the application to be able to provide. And more importantly, Spring Boot provides a sort of a foundation, a framework for collecting these kinds of metrics. So that means that these kinds of metrics can be added on a per project basis. I mean, each Spring Framework project, each Spring project can add some things there. So having this kind of foundation is obviously something that what do you want the application to be able to expose? Any others? Yes? Any plans to support other simple messaging protocols? A lot of the architecture around the Spring Messaging module is independent of, well, it's built to kind of work with simple messaging protocols in general. So STOMP being the first one. We do need another protocol to validate that design, that it's all there. But for example, adding something like MQTT might be a very good target, because it's very similar in some ways to STOMP, but it's also focused on being much more minimal and being able to run on devices that have very little memory or very little, that are constrained, basically, like a microwave or something like that. So MQTT is definitely of big interest, but if you have others or if you have specific stories, feel free to make requests and add reasons. Back there. I guess the JSON view, the main purpose of JSON view is to be able to allow you to make a choice on a per serialization basis. So you may say, this time I want this information, that time I want all the information. So that's kind of the idea for JSON view. OK, thank you very much, and see you around.